Greetings everyone. Welcome to another episode of High School Mathematics. Our topic for today's class is number basis. What is number base? Number base is a system of counting natural numbers in bundles. What do we mean by this? Let's assume we have an object that is 13 in total. Instead of counting one by one, we can decide to count by taking 2 at a time. That means bundles of 2. Counting in bundles of 2 is referred to as base 2 system of counting. Each base has a different name, which we have here. The common system of counting is decimal, which is base 10. We have digits use. Digits use can also be referred to as the coefficients of the powers of base that we are working with. For example, the common system of counting is base 10. Let's have 873. Back in the lower grade, we were taught place value. 873 can be written as the place value of 8 is 100. The place value of 7 is units, is 10. And the place value of 3 is units. This can also be written as you can see that 873 are the coefficients of the base we are working with. That is why we call this the coefficients of the power of the base. We can also refer to them as the numbers that are not up to a bundle. Let's assume we are working with bundle of 2. We have 7. I want to count 7 in bundles of 2. 1. Bundles of 2. Is this up to a bundle? No, it is not up to a bundle. We can call them the coefficients of the powers of the base or the numbers that is not up to a bundle. How are we going to change a number from base 10 to another base? Now we want to convert the following decimal numbers to another base. Convert 25 base 10 to base 2. Mind you, anytime we are given any number with that base, that means they are in base 10. How are we going to convert 25 base 10 to base 2? We will use long division method. Number in base 10, the base we want to convert it to. 25 divided by 2, that is 12, remainder 1. 12 divided by 2, 6, remainder 0. 6 divided by 2, 3, remainder 0. Divide by 2 again. 3 divided by 2, 1, remainder 1. 1 divided by 2, 0, remainder 1. And we move upward. That means 25 base 10 is equals to 11001 base 2. Example 2. Convert 121 base 10 to base 3. Number in base 10, the base we want to convert it to. 121 divided by 3, that is 40, remainder 1. 40 divided by 3, 13, remainder 1. 13 divided by 3, 4, remainder 1. 4 divided by 3, 1, remainder 1. 1 divided by 3, 0, remainder 1. Upward. 121 base 10 is equals to 1, 2, 3, 4, 5. Base 3. Example 3. Convert 805 to base 8. (805) divided by 8, that is 100, remainder 5. Divide by 8 again. 100 divided by 8, that is 12, remainder 4. 12 divided by 8, that is 1, remainder 4. 1 divided by 8, 0, remainder 1, upward. That is 805 base 10 is equal to 1445 base 8. We have 78 to base 16. (78) divided by 16, that is 4. Remainder 14. 4 divided by 16, that is 0, remainder 4. Now, how are we going to do this? We have to start from the down to up. 78 base 10 is equal to 414. This is not okay because we can mistakenly take this as 414 base 16. That is why we have letters here. You can see that starting from the base greater than 10, we introduce letters A, B, C. This A stands for 10. B is 11. C is 12. D is 13. E is 14. Like that. That means instead of writing 14 here, I will have E. We have 4E base 16. With this our example, what will be the answer to these questions? We then move on to the conversion from another base to base 10. Conversion from other bases to decimal. We have to convert the following numbers of different bases to base 10. How are we going to do that? Recall we said earlier that the digits used are the coefficients of the powers of the base. As we have it in base 10, let's say for example we have 963. The place value of 9 is 100, the place value of 6 is 10, and the place value of 3 is units. This can be written as you can also write this as 9 times 10 raised to the power of 2, 6 times 10 raised to the power of 1, plus 3 times 10 raised to the power of 0. You can see that the power of 10 for the unit place is 0. The power of 10 for the 10th place is 1, and the power of 10 for the 100th place is 2. We are going to use this same idea from converting a number in other base to base 10. That means the power of 2 for the unit place here is 0. The power of 2 for the 10th place here is 1. This will be 2 and this will be 3. And we have 1 times 2 raised to the power of 3 plus 0 times 2 raised to the power of 2 plus 1 times 2 raised to the power of 1 plus 0 times 2 raised to the power of 0. This is equals to 1 times 8 plus 0 times 4 plus 1 times 2 plus 0 times 1. 1 times 8, that is 8. 0 times 4, 0. 1 times 2, 0 times 1. And if we sum this, 0 times 1 is 0. If we sum this will give us 10. That means that 1010 base 2 is 10 base 10. Example 2. We have 1110 base 2. 1110 base 2. The power for the unit place is 0, 1, 2, 3. So we are going to expand. That is 1 times 2 raised to the power of 3 plus 1 times 2 raised to the power of 2 plus 1 times 2 raised to the power of 1 plus 0 times 2 raised to the power of 0. This will give us 1 times 8 plus 1 times 4 plus 1 times 2 plus 0 times 1. 1 times 8, that is 8, plus 1 times 4, 4, plus 1 times 2, plus 0 times 1, 12, 14, that is 14 in base 10. Example 3. The same approach, 0, 1, 2, 3. We will expand 2 times 3 raised to the power of 3 plus 1 times 3 raised to the power of 2 plus 1 times 3 raised to the power of 1 plus 2 times 3 raised to the power of 0. 3 raised to the power of 3, that is 27. 3 raised to the power of 2, 9. 3 to the power of 1, that is 3, plus 3 to the power of 0, that is 1. 2 times 27, we have this to be 54, plus 9, plus 3, plus 2. And this is 54 plus 9, that is 63, plus 3, 66, plus 2, 68. 68 base 10. 1 AE base 16. The power for the unit is 0, 1, 2. This is equals to, expand, 1 times 16 raised to the power of 2 plus A. What is the meaning of this A? A is equals to 10. 10 times 16 raised to the power of 1 plus E. E will be equals to 14 because we have A to be 10, B 11, C 12, D 13, and E, that is 14. 14 times 16 raised to the power of 0. 16 raised to the power of 2, that is 256. Plus 10 times 16 plus 14 times 1. This is equals to 256. 10 times 16, that is 160. Plus 14 times 1, that is 14. If we add all this together, we are going to get 430 in base 10. Next example, we have A4C. Base 15. The power will be 0, 1, 2. We now expand. A is 10. times 15 raised to the power of 2 plus 4 times 15 raised to the power of 1 plus, what is C? C is 12. 12 times 15 raised to the power of 0. 15 times 15, that is 225. Plus 4 times 15 plus 12 times 1. And this is equals to 2250 plus 4 times 15, that is 60, plus 12. 2250 plus 60 plus 12. What are we going to get? That will be 2322 base 10. With this, what will be the equivalent base 10 of these following numbers? The next subtopic is conversion from one base to another. We discuss how to convert from decimal to another base and how to convert from another base to decimal. Now, we will deal with how to convert from one base to another base. First example we have here is convert 1101 base 2 to base 3. What are we going to do first here? We have to convert 1101 base 2 to decimal first. And if you want to convert 1101 base 2 to decimal, we will have this will give us 1 times 2 raised to the power of 3 plus 1 times 2 raised to the power of 2 plus 0 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 0. This is 1 times 8, 2 raised to the power of 4, that is 1 times 4, 0 times 2, 1 times 1. 1 times 8, that is 8. 1 times 4, 0 times 2, 1 times 1. And this gives us 12, 13. This is the first step. The second step is to convert the 13 to base 3. 13 base 10 to base 3. And to convert 13 base 10 to base 3, we have to use what? Log division method. 13 divided by 3, that is 4, remainder 1. 4 divided by 3, 1, remainder 1. 1 divided by 3, 0, remainder 1. Upward, that is 111 base 3. That means that 1101 base 2 is 111 base 3. Example 2. To convert 211 base 3 to base 12, we will convert 211 base 3 to base 10 first. This is equals to 2 multiplied by 3 raised to the power of 2 plus 1 multiplied by 3 raised to the power of 1 plus 1 multiplied by 3 raised to the power of 0. This is equals to 3 raised to the power of 2, that is 9. 2 times 9 plus 1 times 3 plus 1 times 1. This is equals to 2 times 9, that is 18, plus 3 plus 1, and we have 22. The base 10 of 211 base 3 is 22. We then convert this 22 to base 12 using long division method. 22 divided by 12, that is 1, remainder 10. 1 divided by 12, that is 0, remainder 1, upward. That will be 1. Are we going to write them to be 110 base 12? No. Since we are dealing with base 12, 10 means A. So we have to write letter A here. That means 1A base. So that implies that 211 base 3 is equals to 1A base 12. Example 3. 1132 base 4 to base 2. 1132 base 4 to base 2. 1132 base 4 is and that is equals to 1 times 3, 1 times 4 raised to the power of 3 plus 1 times 4 raised to the power of 2 plus 3 times 4 raised to the power of 1 plus 2 times 4 raised to the power of 0. This is equals to 4 raised to the power of 3, that is 64. 4 raised to the power of 2, that is 16. 3 times 4 plus 2 times 1. This is 64 plus 16 plus 12 plus 2. 64 plus 16, that is 80, plus 12, 92, plus 2, 94. Next is to convert 94 to base 2. (94) divided by 2, that is 47, remainder 0. 47 divided by 2, that is 23, remainder 1. 23 divided by 2, 11, remainder 1. 11 divided by 2, 5, remainder 1. This is 2, remainder 1. 1, remainder 0, 0, remainder 1, upward. So we have 1132 base 4 is equals to 10, 1111, 0 base 2. The next example, we have convert AE base 16 to base 5. We have convert AE base 16 to base 5. We first of all convert AE base 16 to decimal, which is base 10, and that is AE base 16, this should be 0, 1, and that is equals to A is 10, E is 14, and that is 10 multiplied by 16 raised to the power of 1 plus 14 multiplied by 16 to the power of 0, and that is 10 times 16 plus 14 times 1. 10 times 16, that is 160, plus 14 times 1, 14. The sum of the two is 174. Next is to convert 174 to base 5 using long division. 174 divided by 5, that is 34 remainder 4. 34 divided by 5, that is 6 remainder 4. 6 divided by 5, 1 remainder 1. And 1 divided by 5, 0 remainder 1. AE base 16 is 1144 base 5. Now, what will be the solution to these two questions? Next is to discuss operations of number bases. Operations of number bases, addition, subtraction, and multiplication of numbers are possible if and only if they are of the same base. Examples: 1010 base 2 plus 111 base 2. Before we add these two numbers together, let's have two decimal numbers and sum them together. Let's have 263174. 3 plus 4, that is 7. 6 plus 7, that gives us 13. We have to write 3 and keep 1. How is this possible? Don't forget that anytime we have number without base, that means the number is in base 10, which is decimal. 6 plus 7, that is 13. 13 is greater than the base we are working with. That means we have to divide the result by 10, by the base. 13 divided by 10, that is 1 remainder 3. The remainder is the 3, and we keep this 1. 2 plus 1, 3 plus 1, that is 4. We are going to use this same idea when adding this number together. 1010 base 2, 111, also in base 2. 0 plus 1, that is 1. We are going to write 1 because it is not up to our base. 1 plus 1, that is 2. But it is equal to the base that we have here. What are we going to do? 2 divided by 2, that is 1 remainder 0. We have to write the remainder 0 and keep this 1. 0 plus 1, that is 1. Plus 1, that is 2. 2 divided by 2, we have 1 remainder 0. We write 0. We keep the 1 again. 1 plus 1, that is also 2. The same as the base. Divide the result by the base. 2 divided by 2, that is 1 remainder 0. We write the remainder first. We don't have anything to add again. That is, we bring the 1. Base 2. Example 2. 2012 base 3 plus 123 base 3. 2 plus 3, that is 5. 5 is greater than the base. 5 divided by 3, we will have 1 remainder 2. Write the remainder. Keep this 1. 1 plus 2, 3, plus 1, that is 4. 4 is greater than the base. Divide the 4 by 3, and that is 1 remainder 1. Write the remainder. Keep 1. 0 plus 1, that is 1. Plus 1, 2. Since it is not equals to or greater than the base, we write 2. 2 plus 1, we don't have anything to add here. We bring down the 2, and that is in base 3. Example 3. 4153 base 6. Plus 35 4, 4, base 6. 3 plus 4, that is 7. It is greater than the base. 7 divided by 6, we have 1 remainder 1. Write the remainder. Keep this one. 5 plus 4, 9 plus 1, that is 10. Also greater than the base. 10 divided by 6, that is 1, remainder 4. Write the remainder. Keep 1. 1 plus 6, sorry, 1 plus 5, that is 6. Plus 1, 7. It is greater than the base. 7 divided by 6, we have 1, remainder 1. Write the remainder. Keep 1. 4 plus 3, 7, plus 1 outside, that is 8. Greater than the base. 8 divided by 6, that is 1, remainder 2. Firstly, write the remainder. We don't have anything to add again. Bring this one. Base 6. Next is 1110 base 2 minus 111 base 2. Let's again have two decimal numbers and subtract them from each other. Let's again have two decimal numbers. If we have 6 minus 3, that is 3. 4 minus 7, impossible. Impossible. Let's again have two decimal numbers. 6 minus 3, that is 3. 4 minus 7, that is impossible. What are we going to do here? We will borrow 1 from 3. This will be 2. And this will be 14. How is this 14? Don't forget that decimal is in base 10. We have base 10 here. When we borrowed 1 from this 3, the one that we borrowed from 3 will turn to the base that we have here. We borrowed 1 and that one turned to base. And the base is what? 10 plus 4. That is 14. That is why we have this to be 14. 14 minus 7, that is 7. 2 minus 1, that is 1. We are going to apply this same idea when subtracting in other base too. 0 minus 1, it is not possible. We borrowed 1 from the next number. This will turn to 0. After we have borrowed 1 from this one, the one that we borrowed will turn to what? The base that we have here. And the base that we have here is 2. 2 plus 0, that is 2. Now we have 2 minus 1. We have this to be 1. Again, this 1 has already changed to 0. 0 minus 1, it is not possible. Borrowed 1 from the next number. The one that we borrowed, we change to what? We change to the base, which is 2. 2 plus 0, that is 2. We now have this to be 2. 2 minus 1, that is 1. Also, 0 minus 1, it is not possible. Borrow 1 from the next number. This will turn to 0. The one that we borrowed, we what? We change to the base, which is 2. 2 plus 0, we have this to be 2. 2 minus 1, that is 1. This is 0. We don't have any need to write this. So that means 111 1110 minus 111 will give us 111 in base 2. Next example. We have 423 base 5 minus 244 base 5. 3 minus 4. It is not possible. Let's borrow 1 from the next number. This returns to 1. The one that we borrowed from 2, we turn to what? We change to 5. 5 plus 3, that is 8. We will have this to be 8. 8 minus 4, that will give us 4. We have 1 here. 1 minus 4, it is not possible. Borrow 1 from the next number. We will have this to be 3. The one that we borrowed, we change to 5. 5 plus 1, that is 6. So we will have 6 here. 6 minus 4, that will give us 2. 3 minus 1 minus 2, that is 1 base 5. Next example. 7A4 base 12 minus AB base 12. What is the meaning of A? A stands for 10 and B is 11. 4 minus 11, that is not possible. Borrow 1 from the next number. This is 10. If we borrow 1 from it, it will be what? 9. The one that we borrowed, we turn to 12. 12 plus 4, that is equals to 16. We will have this to be 16. 16 minus 11, that is 5. This is 9. 9 minus 10, it is not possible. Borrow 1 from the next number. This will turn to 6. The one that we borrowed, we turn to what? 12. 12 plus 9, that is 21. We have this to be 21. 21 minus 10, that is 11. But we are not going to write 11 like this. What is the meaning of 11? That is B. We have this to be B. We don't have anything here. That is only 6. 6. Bring down the 6. Base 12. The next example is 1101 multiplied by 1, 1. Let's also have 2 decimal numbers again. We know that decimal is in base 10. 3 times 5, that is 15. We are not going to write 15. 15 is greater than the base, which is 10. 15 divided by 10, that is 1, remainder 5. We will write 5. Keep 1. 3 times 4, that is 12. Plus 1, that is 13. Divided by 10, write 3. Keep 1. 3 times 2, that is 6. Plus 1, 7. 2 times 5, that is 10. It is equal to the base that we have. 10 divided by 10, that is 1, remainder 0. Keep 1. 2 times 4, that is 8. Plus 1, 9. 2 times 2, 4. What are we going to do next? We are going to add. Bring down 5. 3 plus 0, that is 3. 7 plus 4, sorry, 7 plus 9. 7 plus 9 is 16. That is greater than the base that we have. 16 divided by 10, that is 1, remainder 6. We write 6, keep 1. We have only 4 here. 4 plus 1, 5. This same idea will be used when dealing with multiplication under different base. 1, that's 6, 7. 1101 base 2 multiplied by 11 base 2. 1 times 1, 1. 1 times 0, 0. 1 times 1, 1. 1 times 1, 1. 1 times 1, 1. 1 times 0, 0. 1 times 1, 1. 1 times 1, 1. What are we going to do next? Plus. Bring down the 1. 0 plus 1. 1 plus 0. 1 plus 1, 2. This is equal to the base that we have. 2 divided by 2, 1 remainder 0. Write the remainder. Keep 1. 1 plus 1 again, that is 2. It is equal to the base that we have. 2 divided by 2, 1, that is 1 remainder 0. First of all, write the remainder and the remaining 1. We have this to be in base 2. The next example, example 8. One times 2, 2. 1 times 2, 2. 1 times 1, 1. 2 times 2, that is 4. It is greater than the base. 4 divided by 3, 1 remainder 1. Write the remainder. Keep 1. 2 times 2, 4. Plus 1, 5. That is greater than the base. 5 divided by 3, that is 1 remainder 2. Write the remainder. Keep 1. 2 times 1, that is 2. Plus 1, 3. 3 is equal to the base that we have. 3 divided by 3, that is 1 remainder 0. We then add them together. Break down the 2. 2 plus 1, 3. It is equal to the base. 3 divided by 3, that is 1 remainder 0. Write the remainder. Keep 1. 1 plus 2, that is 3. Plus 1, 4. 4 is greater than the base. 4 divided by 3, 1 remainder 1. Write the remainder. Keep 1. We have 0 here. Plus 1, 1. And this 2 will be 1 in base 3. The next example is 3104 base 8 multiplied by 34 base 8. Four times 4, that is 16. Greater than the base. 16 divided by 8, that is 2 remainder 0. Write the remainder. 0. Keep 2. 4 times 0, 0. Plus 2, that is 2. 4 times 1, 4. 4 times 3, that is 12. Greater than the base. 12 divided by 8, we have 1 remainder 4. Write the remainder. Bring the 1. 3 times 4, that is 12. Divided by 8, 1 remainder 4. Write the remainder. Keep 1. 3 times 0, 0. Plus 1, that is 1. 3 times 1, 3. 3 times 3, that is 9. Greater than the base. 9 divided by 8, we have 1 remainder 1. Write the remainder first. Plus. We sum it together. Bring down the 0. 2 plus 6, 2 plus 4, 6. 4 plus 1, 5. 3 plus 4, 4 plus 3, 7. 1 plus 1, 2, and 1. base 8. With this explanation, what will be the answer to these three questions? This is the end of today's class. Thank you for watching. Don't forget to like, subscribe, and share for others to learn. See you in the next class.